Friends, welcome back to my channel. In this video we are going to discuss the PFC power factor correction circuit in this power supply of PS4. It is ADP-200ER. What is power factor correction? I applied 115 volt, 116 volt at input, and I am receiving. So I applied 116 volts. So I am receiving 164 volts. 116 square root 2, it should be 164 volts. To take peak voltage at capacitor, so 164 volts. I am taking exactly as per our calculation 164. So you can calculate it as well, multiply it by 1.414, it is the same, 164 volts. When we try to power on this circuit, I connected this switch. This switch is connected between 5 volt and AC/DC standby. I connected a switch between 5 volt and AC/DC standby. So I connected 5 volt AC/DC standby, these two pins. This time I am not taking output in the 12 volt section, and we have 164 volts at main capacitor. This time I applied 116 volts. Now I am going to turn on this switch. When I will turn on, because I connected series lamp, I powered on. Our PFC circuit maintained this capacitor at 411 volts, and now this supply started output. It is 11.86 volts. Here 410 volts, and at input the same 116 volts. 116 volts. As per calculation, we should have 164 volts, which we calculated here. This is our 116 voltage input, and to determine the peak at capacitor must be 164 volt. But now we are taking 411 volt, 410 volt DC. So how is this possible to generate voltage 411 volts instead of 160 volt? So these additional voltage are replenished, are created, are boosted by this circuit, this inductor, MOSFET, rectifier diode, and one IC, and some related components. When I applied 116 volt, 164 volt here, and when I turned on the power, this capacitor charged at 410 volts, 411 volts. What is the reason? Because here we need a huge amount of current, that is 12 volt 16 ampere, to make from 160 volt, or we can say 120-30 DC volt. Maybe here, if here is 85 volt, if input voltage are 85 volt, lower range of 115 volt. So in that condition, we will take 120 volt DC. If we have 265 volt AC input, capacitor will 374 volt. So if there is no PFC circuit and we want to increase the voltage, we want to take output from this circuit, it will very difficult to maintain the regulation, because the input voltage will vary from 120 volt to 374 volts. In that case, the regulation factor will affect it directly. Okay, now I am going to connect 220 volts instead of 116 volts. Then we will see the response of this circuit. AC, it is 234 volts. Now we will check DC voltage. It is 333 volts. 235 volts multiply by 1.414, it is 332.29. You can calculate by square root 2 or you can calculate it by 1.414. So it is okay now. As per our calculation, the output of bridge rectifier, that's okay. 331 volts. No power at output, and we are just taking the standby voltage. Standby voltage, this point and this point, 4.8 volts. That is standard output of this power supply from this small section. I discussed this section already, and I discussed this DC rail circuit and input protection circuit in our last video. When there is just only this circuit working, when 160 volts were on this capacitor, we were taking 5 volts. Now input is here 333 volts DC voltage, and we are taking 5 volts. So this circuit will work at 160 and 330. We need output from this circuit. When we turn on the power on button from our PS4, PlayStation 4, actually what happens, these 5 volts are applied to AC-DC standby switch. Now I turned on. So this circuit, this PFC circuit, maintained voltage again and at 411 volt, regardless to the input. Either it is 85 volt AC, 110 volt, 200, 230, 260 volts. It will maintain the DC level at 411 volts when we need output. 12 volts, it is 12 volt, 11.86 volt. So that means this circuit is responsible to maintain the DC voltage level at 410 volts, because this circuit needs 410 volts to work properly, to give a proper output without any drop, without any load effect, to maintain the load regulation, to maintain the line regulation, to give a proper output. So it needs 410 volt to turn on. So let's see how it will boost the voltage. Come to this point. This is our input circuit. Here we have input voltage, AC input voltage at bridge inner pins. So these voltage are rectified at bridge to charge this capacitor, and these voltage, rectified voltage, are reached here through this NTC is here, and through this inductor. This one is not a transformer, it is inductor. It is a coil, it is a choke. So voltage will pass from this PFC choke from this point to this point, and here we have a rectifier diode. Normally voltage rectified through NTC, this positive and negative voltage, are reached here at PFC coil and diode output. This diode D11 is here. This one D11 is here. So we have a point, common point here, which will allow the voltage to pass to the capacitor. Now we have to see the function of this PFC, how it is boosting the voltage. Here is IC2PCS02. 2PCS02. It is standalone power factor correction controller in continuous CCM mode. Any power factor correction. PFC circuit, it is very common used in inverter AC boards, in LED power supplies. We have a positive voltage here. We pass it through an inductor, and after inductor we connect a MOSFET. PFC controller, it checks the voltage, how much voltage are present here. If the voltage are within limit, it will remain silent and this MOSFET switch will remain open. When voltage will drop, it will start switching. When it will start switching, the voltage coming to this point here will take a surge, and it will cause a heavy current flow in this path, because here is a shunt resistor. This is I-sense or I-sense, current sense resistor. It is very low ohm, and this one is very low ohm. So what will happen? It will cause to generate a magnetic field, because this is high amount of current. High amount of current will flow here, so it will cause to generate a strong magnetic field. When it will cause to generate a strong magnetic field, this end is positive, this end is negative when the current is flowing, because this negative end is connected through a short source. Its on resistance is milliohm. So this end will negative, this end will positive. In the off time, when this switch is open, what will happen now? Here a strong magnetic field is built up in the on time. Now the magnetic field will collapse. When the magnetic field will collapse, it will cause to induce a reverse voltage. In first condition, we applied voltage positive to this inductor. We applied voltage to this inductor. This one end was positive, this end was negative. Now this magnetic field have to collapse. When it will collapse, it will induce voltage to the reverse polarity to the applied voltage. So now, due to voltage collapse, this end will become positive, this end will become negative. Now this end will become positive, and its voltage level will proportional to the magnetic field. How much magnetic field has been induced? Now if we look here, positive, negative. This end is negative, this end is positive, negative, positive. If we consider this capacitor as a battery cell, negative, positive. Now this inductor will behave as a battery, as a voltage source, negative, positive. So our two sources will become in series. So we have no path here. There is no return line. So voltage have to pass through this diode. For example, 200 volt were here at this capacitor. We applied a drive pulse and it caused to flow a heavy current in this path. So it will cause to induce magnetic field in this coil. So when this magnetic field is built up and the drive pulse is stopped, now the off time is started, so this switch is open. So magnetic field will collapse. While collapsing magnetic field, it will cut the inductor, the coil. So it will generate voltage, and these voltage always reverse to the polarity of the applied voltage. First this end was positive, now this end, while collapsing, this end will become negative, this end will become positive. Capacitor positive end, inductor end is negative. Next we have diode rectifier. So it is one-way conductor, so it will allow just only one direction current flow. Now we have to assume this capacitor as a battery. Now two batteries are in series. One battery is working as a capacitor, second battery as this inductor. So it is working as a voltage source. When two sources are series, negative, positive, negative, positive, and when this end is positive, this diode will forward bias. When it is forward bias, so voltage will be pumped into this capacitor, and this capacitor will charge at how much voltage? For example, 200 volt were here at capacitor. 200 plus 200, 400 volt. So capacitor will charge at 400 volt. And this controller will also sense the voltage level, and it will increase or decrease the switching time to maintain the voltage at this capacitor. How much we need? It depends upon our design, and it will adjust its duty cycle. First of all, check voltage at this capacitor, because this time I turned on the system and it is 411 volts. So that means the power factor module is working. The same 400 volts are applied to these MOSFETs. Now the pin number 7, that is VCC. It is taking 14.55 volts at VCC pin. Pin number 6 have 3 volt. Pin number 5 have 1 volt. That is V compensation. Pin number 6 is feedback input, sense feedback. Pin number 4, that is brown out sense. It is taking 4 volt. Pin number 3, 0 volt. Pin number 2, that is I compensation, current compensation. It is 1.2 volt. Pin number 1 is 0 volt, that is ground. Drive is at pin number 8. So it is driving the this gate, and it is making switching this MOSFET, and we are taking voltage at bulk capacitor. When I will turn off this command, so PFC circuit will turn off and the voltage will be maintained at 330 volts. So friends, in next video we will discuss this high voltage section, 16 volt, 12 volt, 16 ampere, and in the final stage we will discuss this IC, that is power supply control, and this is operational amplifier that will sense all the inputs, voltage level, and it will give a so this gate drive will varied depending upon the voltage, input voltage, how much voltage we have at input side and how much voltage we have at capacitor. When here is, for example, we have 100 volt here, so that means 140 volt will here. So 140 volts, it will sense the voltage. What is the level of voltage? How it will sense? We have these sense resistors 1, 2, and it will feed the voltage to this pin, to voltage sense pin. So it will sense the voltage because this is the output of the diode. Here we have rectifier diode. So this line, it will sense the voltage from this point, this resistor, the second resistor, and it will come to this point, this resistor, 1, 2, 3 resistors in series, and it is connected to pin number 6 here. So this is pin number 6 is V sense. I sense, V sense. I sense how much current is flowing from this current limit resistor, current sensor resistor. The amount of current is applied through this resistor, and the amount of voltage will sense 1, 2, 3 resistors. So it will sense the amount of voltage. So this IC will maintain its duty cycle to maintain the voltage level 410 volt at this capacitor. So friends, I hope so this video is informative for you. If it is informative, and if you have not subscribed my channel, If you want to watch my future videos, then subscribe and press bell icon button to watch my future videos and to get me notified. If you have any question, let me know in the comment box. And if you have any suggestion, if you have any correction, please write in the comment box. I will welcome your comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.